Okay, so let's start today's discussion about planes in 3D space, which basically looks like this. To solve intersection of three planes, we are going to use Cramer's rule. Cramer's rule is a method to solve system of linear equations. Method uses determinants and provide a solution for each variable by using the ratio of determinants of matrices. So here you can see the formula to find out values of x, y and z, and in this way solve the equation of linear system. Now there might be cases when the solution is not existing. So if we look clearly, if the determinant is 0, then the planes are going to intersect at a single point and there will be a unique solution. And in all other cases, if determinant is equal to 0, then there will be no solution or infinitely many solutions. In this question we are given three linear equations which basically represent three planes in three-dimensional space, and to solve for the intersection of these three planes we are going to find out determinant to use Cramer's rule. And in our equation ax equal to b, we are going to first find out the determinant of a, and I have written determinant of a, and I have separately solved the determinant of a, which you can see in a while. I will be giving the solution. Here you go. So these are the solutions for finding determinant a. In option a plus b plus c is not equal to 0, and a square plus b square plus c square is equals to ab plus bc plus ca. So we see that the second factor a square plus b square plus c square minus ab minus bc minus c is going to be 0 with the condition given. And also we can rewrite our second factor a square plus b square plus c square minus ab minus bc minus ca, and determinant a is obviously going to be 0, so we are not going to find a single solution. There will be no solution or infinitely many solutions. So we are rewriting this factor as this 1 by 2, and in parenthesis a minus b whole square plus b minus c whole square plus c minus a whole square, which is 0. And so we can conclude something important from here. What is that? That these are all positive numbers because they are basically the squares. So all the squares are summing up and giving 0. It can only happen when they are individually equivalent to 0. So a minus b is going to be equal to 0, b minus c is going to be 0, c minus a is going to be 0. From there we can conclude that a is going to be equal to b, b is equal to going to be c, and c is going to be equal to a. That means a is equal to b is equal to c. Let abc is equal to k, and we rewrite the equations of plane 1, 2 and 3 by replacing a, b and c by k, and we get the plane 1 equation as x plus y plus z equal to 0, and we are going to get all other two equations of plane 2 and plane 3 as x plus y plus z equal to 0. All the planes have the same equation. Plane 1, 2 and 3 are identically basically, and we can also say that all the planes are coincidental, and in that way there are infinitely many solutions of x, y and z which are going to satisfy this linear equation system. And you can also go back to the slide where I have provided conditions and how many solutions will there be, and in our option A we are going to match it with option R. The equations represent identical planes. So now moving to the next option B, which is a plus b plus c is equal to 0 as a condition. So obviously determinant a is going to be 0. Once again there will be infinite many solution or no solutions at all. and the second factor, which is by the condition not equals to 0. Also, if we rewrite it in another form like a minus b whole square plus b minus c whole square plus c minus a whole square, from there we can conclude that a is not equal to b, not equal to c. And from condition a plus b plus c is equal to 0, it can be concluded that a, b, c are some distinct numbers. So a, b, c are distinct numbers, and all the three planes have equal to 0 in place of d1, d2 and d3. So whatever we multiply with a in first equation and multiply with a in second equation and multiply with a in third equation must be same, and same goes with b and c. Whatever is getting multiplied with b in first, second and third equation must be same, and whatever is getting multiplied with c in first, second and third equation must be same, so that all the three equations give right hand side as 0. For getting a more clear understanding, here I have rewritten the planes equation, and coefficients are in same order, like a as first position, b in second position and c in third position. So for all the first term in all three equations, to give an output of same value, as a is going to be same, x, y, z must be same. Also for the second position term, by, bx, bz must have same value because b is going to be same, and same goes with the c. So x, y and z are going to be same, and all the three equations of planes are satisfied with x equal to y equal to z. And one more thing, x, y and z together can have a lot of values, so there are going to be infinite many solutions. And if we go back to our condition of Cramer's rule, they are making a single straight line, and we check our options. So option B is going to match with the option Q, where the equations represent the line x equal to y equal to z. And here is a visualization in 3D space how the sheaf or a single straight line is made by intersection. Now in our option C, a plus b plus c is not equal to 0. It is having some value, and also other factor is not equals to 0. That means the determinant a is going to be not equal to 0. So all the planes are intersecting at a single point, and there is a unique solution. And if we use the Cramer's rule for finding x, y and z, we see that d1, d2, d3 is 0, and that is going to give x, y, z as 0. So now if we look at our options, we can match C with B. The equations represent planes meeting only at a single point. Also, I have provided here a space visualization of three planes intersecting at a single point. So now moving on to our next option D, a plus b plus c is equal to 0, and by using another condition, a square plus b square plus c square equal to ab plus bc plus ca, we rewrite the other factor as a minus b whole square form, and then by using some simple math we found out that a is equal to b is equal to c. Okay, so now using this solution we go back to our planes, and we found out that these equations of these three planes will get satisfied regardless of the value of x, y, z. A, B, C are 0. So x, y, z can attain any value in 3D space. So basically Our equation of planes are representing a three-dimensional space. We can rewrite xyz as belongs to R cube or 3D space. Our option D matches with the option S. And now in the end of the video, I have added a specific situation where three planes make a triangular prism by intersecting, and here also there are no solutions. Determinant will be 0. That's all for today.